Okay, about a year ago, when my daughter was born, we decided to ask all of our family members to write her letters. And we will give her all these letters when she turns 18. You know, imagine it's your 18th birthday and you get all these old letters from your great-grandparents from California and your great-grandparents from the Czech Republic, all handwritten and full of wise advices. Now, I was probably not supposed to read those letters, but I did look at the one on the top. I started reading. It was the one from my younger brother. And I just couldn't stop. You know, it made so much sense. He was talking about the purpose of life and how to be happy. And his message was basically, no matter what you do your best. You know, do it the best way you can at that moment. And that was when I decided to do this talk, because for the past 6 years or something, I've been doing programming. I've been writing software. And so I've been searching for a way how to produce quality, you know, software that I can be proud of and I can feel good about. Well, I still haven't figured it out, but I'm pretty passionate about it. So I decided I will share it with you, what I learned so far, and maybe suggest some directions that I think we might explore a little bit more. So here's one example of something that I'm really not proud of. It's our Angular CI server on Travis, you know, and I'm actually pretty frustrated about it because I spent past year, maybe year and a half, trying to make this thing reliable. And yet, when I come to office, what I see most of the time is something like this. You know, this is our dashboard, and it's broken. Now, this doesn't mean that the code is broken. I mean, it doesn't mean that the tests are failing. But it's all kind of weird issues like this browser disconnected, or that browser didn't even start, an npm install failed, and I don't even know what. And it was not just me. You know, it was many other colleagues on my team, like Igor, Tobias. They tried to fix it too, and nobody knows. You know, nobody knows how to fix it. And I think it's even worse. I actually think that most of the software is broken. You know, this guy, he is one of the Linux kernel maintainers. He knows what he's talking about. And thank you. And I think this will be way more bigger problem because we are relying on technology and software more and more. And I think the biggest problem is that we don't understand it. You know, we don't know why it's broken. Also, there's still this kind of human intervention, right? But as this is kind of slowly disappearing, you know, I mean, think about self-driving cars and stuff. I think, again, it will be even bigger issue. For instance, last week, I was supposed to pick up my sister. She works in San Mateo in like local coffee shop. And so she texted me the name of the place. It was called Cafe House. And so I put it in my phone, you know, in the maps, and like click, whatever, navigate. And then before I started driving, it was like, wait a minute. It was navigating to Cafe House in Hong Kong. You know, I live in California, so I mean it's the same planet, but not quite close. But because there was this human intervention, when I look at it, I was like, oh, this is bullshit. I just closed the app and navigate myself. I was okay. But I mean, self-driving cars or something that, if there's no this human intervention, I think, you know, I would probably still be on my way to Hong Kong. Okay, enough complaining, I'm sorry. Let's forget the broken software and let's talk about something pretty. I got some pictures for you, like Golden Gate Bridge. If you guys go to San Francisco, you should definitely check out the Golden Gate. It's pretty amazing. Or this is really awesome picture. That's Tower Bridge in London. You probably seen this one, right? If you didn't, you can go check it out. This one is in Paris too, Cathedral Notre Dame. Now, why am I showing all these pictures? Well, I think that building or designing buildings has a lot in common with designing software. You know, if you think about it, you need a lot of people to collaborate together to design or build buildings like this, and it's the same with software. Also, when you're building a house, you use these little bricks and you put them together to build bigger things and bigger things. And it's kind of a similar technique we use in software as well. At the end of the day, buildings their purpose is to serve us humans, which is the same as software. So there's this aspect of usability or something. Many people think that buildings are different because they are very static. You know, they exist in a static environment, and software is so dynamic and everything keeps changing. I actually don't think that's the case. Because if you think about weather, you know, there's like different temperature and different wind and geology, and I mean even the interaction with humans or animals is just, it's very dynamic, I think, and often unpredictable. So my point is that I think designing buildings and designing software has a lot in common. There is one difference though. This cathedral is about 700 years old. It's like 30 generations. And you know, it's still there. I saw it yesterday. So show me software that lasts that long. I mean, most of the software is like ready to be rewritten over 2 or 3 years. And I got better examples like this. It's Colosseum in Italy. That's like 2,000 years. Or, come on, pyramids. That's 4,000 years. They're still there, still works. So the question is, can we learn from these architects? I mean, how did they do that? How did they achieve this? Well, my mom is an architect, and so I talked to her. I asked her all these questions, like how they do these things. And I was almost shocked how much math it is in architecture. You know, they use math to make sure that it's durable. So things like how thick this wall needs to be and how far apart you can put these two columns and what material you can use for a roof and all kinds of stuff like that. Then they use math for usability, like things like how many steps it is from bedroom to bathroom and from kitchen to dining room. And they have equations for stairs, you know, to compute like the proportion of height and width of stair and the angles so that it's pleasure to walk these stairs. And third thing, that was really not obvious to me at first, that's aesthetics. You know, like maybe things like how many different colors you can put together or how many different materials you can put together to still keep it consistent and look good. And I think this is really interesting because it's kind of related to like sound, for instance, how our ear perceives sounds and different combinations of sounds. Usually it's kind of small numbers sounds good to our ears, and it's the same visually. Anyway, this is interesting, but the point is that they use a lot of math. And so I think we need more math. And that's why I have a mathematical joke. It's okay. I mean, we'll work on it. I mean, you're supposed to laugh. But, I mean, we'll get there. In the meantime, I got a bear joke, and unfortunately, it's kind of hard to see. So I will read it. I changed all my passwords to incorrect, so wherever I forget it, it will tell me your password is incorrect. That one is not related to my talk, but it's pretty good, I think. Okay, let's go back to software then. How can we apply more math? Well, I got 2 concepts that I would like to show you. And you know, try to think about it as we go through these examples. How could you apply that to your project or your code? These 2 concepts, I got pure functions and immutability. So the first one, pure functions. Pure function is basically a function that you know from math. So it only operates on its inputs, and it has no side effects. And also for the same set of inputs, it will always give you the same result. Right? Nothing new, you've heard it many times. I just want to demonstrate like some of the benefits. So here's an example. I think I'm gonna go here. It's some compiler, it's in JavaScript. So maybe something like Tracer or Clojure compiler or Uglify or something like that. And so we get method parse that takes string code, and it parses this code into something called AST, basically tree representation of that code. And then we put this tree into instance variable this.currentTree. Right? I didn't write all the code to do the actual work, but that's not the point here. Then we get method transform, which takes this tree and transforms it. So you could do things like inline function or rename properties or eliminate unused code and all kinds of stuff like that. And then last step is write, which is you take that tree and you basically serialize it back to the code, so you get back string. Here's how you could use it. So you instantiate it and you call parse. You parse some source code, which will create the internal tree of it. Then you transform it, and you get back the transform string source code. Now, look at the parse and transform calls. Come on, you silly. How about, can you swap these two lines? Like this? Like this is perfectly valid code, but it won't work. Because in the runtime, you can't call transform before parse because there's no tree to transform, right? But my point is that, so the order does matter, but it's not obvious. I need to look into the compiler code to know this, right? Okay, another thing. How about if we call parse twice, we parse another source code before transforming the first one? Well, the first code, we're gonna lose that, right? Because the second code will override it, the tree will get overridden. Now again, this is something, maybe it is obvious, but the point is it's wrong, and this source code, this code is like, if you do some static check, like type checking and stuff, this is perfectly valid. So here is an example using pure functions. It's the same thing. You get parse function that takes string, source code, and returns the tree, the parse tree. Then we have transform function, which accepts one input argument, that is tree, and it returns transform tree. So a new tree that is transform. And last, again, the same thing, write function that takes the tree and returns string. Now, in this case, the order of transform and parse, it still matters, but I can't do it wrong, right? Because transform accepts the argument, so I need to call the parse first to get the tree, right? Or, I need to create a tree somehow. So my point is, yes, the order still matters because that's just what it is in my app, but I can't do it wrong without understanding how internal compiler works. If I decide to parse two strings before transforming the first one, there's no problem. I just have two trees, so I will transform the second tree as well, and everything is good. I'm not losing anything. Notice how these two source codes that we are parsing, they're almost the same, right? There's just some white space differences. And so it turns out that the trees, like the meaning of the code is the same. And so the tree and the tree 2, they are the same. And so when we are calling transform, this transform function does all these smart transformation on that tree and returns transform tree. But when we call it again with the tree 2, this function or the VM can say, I saw this tree already, and I know how transform tree, like how this tree transformed looked like. So I'm just not going to execute this function at all. I'm just going to give you the result, and I can skip that. Now, this is only possible because this function is pure. There's no side effects. Right? It's like in math, you call function to get a value. If you have function call with arguments, like with values as arguments, you can interchange it with the actual value of the function call. It's the same. Nothing will change. But in the previous code, with these methods that have side effects, you can't do that. Because we call these methods to do work, to like mutate the universe or something. And also, these methods, they behave differently based on this universe or whatever it is. So it's like, I don't know, like it's like if mathematical functions like sine, cosine, tangent, if they return different values based on the current weather, right? Or like you can call sine only if it's sunny. If it's raining, it will throw exception. Like it's like, it's pretty ridiculous. Good luck building pyramids with that. You'll need like 4,000 years weather forecast. So I think it is pretty insane, but we do this all the time. Okay, so that's pure functions. Now the second concept I want to show you is immutability. That means you get immutable value or object, so once you create it, it will never change. Again, nothing new. You saw it many times. I want to just show you, again, some benefits of that, and hopefully I will show you also how I think it's very tightly related to the pure functions that we just talked about. So again, here's example. This is actually simplified code from Karma. So we got some config object, and we got web server, and we got launcher. Launcher is the thing that starts browser. The dependency graph is super simple, right? Like server depends on config, launcher depends on config. Now if you look at inside the launcher, what it does, it just starts Chrome process and gives it one argument with the URL that Karma is listening. Simple. The web server is a little bit more interesting. It starts listening on the given port. And look what happens when there is error. Like if there is some other process already listening on that port, what happens is that Karma tries another port. Right? That's a pretty good feature, I think. But look how it's happening. It mutates the config object. Right? Can you see it? Like it mutates its config object, and so there is this hidden communication between web server and the launcher, right? Because the launcher uses the config port as well. And so as long as you call this launcher start after the web server is already listening, everything will work fine because the web server mutated the port before this guy reads it. But how about you get a pull request with refactoring like this? You know, this looks super innocent. Like there's nothing wrong with it. Just extracted to variable. It's more easy to understand maybe. And now it won't work. This won't work because now we're constructing the URL before the web server mutates it, and so we get the old port. And this is really hard to reason about. I mean, if you want to understand this, it's not enough to understand this single object. You need to understand way more outside of the scope of this object. You probably need to understand the entire system and know when what is mutated. You know, it's kind of similar problem. It's again problem of order of things. In this case, it's order of mutations that really matters. But it's not obvious. You know, we're working with this object that like mutates and we don't know even when, and it makes it really hard. It's like if Brett asked me to count people in this room, you know, I can look and start counting like 1, 2, 3, 4, 5, and now that guy moves and somebody starts leaving. I'm like, oh, wait, like I don't know, like how am I gonna do that? I mean, at the end I'll just probably say something like, hey Brett, there was about 700 people. But I don't know because they were moving and somebody was leaving and, you know, I just don't know. Wouldn't it be better if I just took a picture and, you know, sit down and cross out everybody's head and say, you know, there was exactly 736 people at this particular time. I mean, maybe it wouldn't be the latest number, but it would be correct. Like with the timestamp, it would be correct. And I think that's much better. So in this case, I would probably rather pass the config in the start function and make the config immutable. By the way, all these examples, like these concrete refactorings, like that's not, the point is more general, you know? Like I'm not saying that you should change all this code like this, but it's just to demonstrate how bad it is to work with things that keep changing. So here's the connection between immutability and pure functions. You remember when I was talking about pure functions and we had this transform function and we passed it this tree object, and when the tree was the same, we just didn't execute the function at all. We just say, oh, I know this result, so here is the result. That's cool. But in real life, this input, in this case it was this tree, it can be pretty huge structure. And so just to decide whether you already saw this input, it can be really expensive and pretty hard. Does it sound familiar? It's like, you know, Angular dirty checking. It's the same thing. And so it's often just easier and faster to just call that function no matter what and don't worry about this. How about if all the inputs were immutable? You know, if all the inputs were immutable, this dirty checking would be just a piece of cake. Like it's just one reference check. Because you know, if it's the same object, exactly the same object reference, it didn't change. Because the object is not allowed to change, right? So here is an idea for you to think about. If we could use persistent data structures that's like immutable data structures, just a little bit smarter. If we could use persistent data structures, things like dirty checking would be so much simpler. And things like local digest, which is now, I would say, impossible, it would be just a piece of cake. So think about it. Okay. So I think these two little examples, like being careful with mutable shared state and looking for places where we can use more pure functions, I think these are just tiny little examples of going to direction of more predictable software and maybe more formal reasoning. And as I said at the beginning, I don't know what the end solution is, but I think this direction is really worth exploring. So if you find anything interesting, here is my contact. I don't think you can really see it, but well, that just means that you need to find me here and talk to me in person, which is even better. And yeah, I would love to hear your experience and your opinions and ideas. So please do find me. And yeah, I hope that answer to this question is yes. I hope we can learn from architects, and I hope we can produce software that there's quality and software that we can feel good about and we can be proud of. Thank you, guys. Enjoy the conference. Thank you.